This is assignment 34, density note taker. Please fill out the page as you follow my instruction. We're starting here with this concept of per. It's very, very important in chemistry that you understand this concept. It is a ratio. A ratio is relating two different units of measurement with a line in between. That line is the word per. My first example is something you've all heard of, 45 miles per hour. 45 miles on the top, 1 hour on the bottom, with the line in the middle being per. 45 miles per hour. This is not a number, it is a ratio. For example, we could rewrite this as 90 miles in 2 hours. That's still 45 miles per hour. So it's not a number, it's a ratio. We could change the units of measurement and say, yes, it's 45 miles in 60 minutes. Mathematically, this looks very different. So this is where the labels are essential, and you realize these are all the same ratio. We are focusing on density. Density is a ratio of mass to volume. Mass is how heavy. Volume is how big, how much space the object takes up. These have units of measurement. Most commonly, we use these. Grams for mass. Per is the line. Cubic centimeters of volume. So grams is mass. Cubic centimeters is a volume. Per is the line. Number 3 talks about little cubes. You saw these little cubes on Monday. Each little cube represents a volume. How much space is this? It happens to be 1 cubic centimeter. I will show you why it is called that using a ruler. But the abbreviation for cubic centimeter is cm for centimeter, with a cube up top saying we're cubing that. The reason this is called a cubic centimeter is because if you measure the length, width, and height, it is 1 centimeter by 1 centimeter by 1 centimeter. So it is a centimeter cubed, a cubic centimeter. Now, number 4 is talking about a specific substance. We can make these little cubes out of anything you want, or at least we can imagine doing that. So now let's imagine the cube is made of copper. Each little cube would have a mass of 8.94 grams. This means the density of copper is 8.94 grams per little cube, per cubic centimeter. Per cubic centimeter. This is usually abbreviated because people don't want to write that long word, and so they usually abbreviate it this way. 8.94 grams is G. This slash is the line. This slash is the line between the top and the bottom of the proportion. 8.94 grams per cubic centimeter. The words here say that you should write this 8.94 grams per cubic centimeter as a ratio. Please do this. It's the key to the whole thing. 8.94 grams is a mass. Line is per. 1 cubic centimeter is the volume. It is a ratio between these. We can do some calculations now, a simple calculation. Let's imagine I have 6 little blocks of copper. If I had 6 little blocks of copper, I could calculate their mass. 6 little blocks, 6 cubic centimeters. What would the mass of that be? So here I can solve for the mass of 6 cubic centimeters of copper using simple algebra. I'll cross multiply, and it looks simply like x equals 8.94 times 6. And I will not put labels on these numbers yet, but I will put a label on my answer. So 8.94 times 6, I get 53 7.64 grams of copper. Number 5 says that density values for elements are shown on the periodic table. So instead of my needing to give that to you, you can find them here in this sector of your periodic table. Not all the elements are listed, but enough that you can get a lot done with this. All right. Number 6 says, let's imagine that these cubes are not made of copper, but are instead made of iron. What will the mass be? So, use the density ratio from the periodic table. Write it as a ratio. So here I would find iron, 7.86 grams per cubic centimeter. 7.86 grams per cubic centimeter. Number of cubes at my table, 6 cubic centimeters. Now I can solve for x. So you try to solve that before I show you the answer. Pause the tape. Here's my algebra, 7.86 times 6. And I will get, on the calculator, 47.16. Label is grams. The substance is iron. If I think about this, this makes sense that the density of iron is less than the density of copper. So with copper, these cubes would weigh 53.64 grams. With iron, they weigh a little bit less because the density, the amount of mass in each cubic centimeter is lower. Volume is same, mass is different. Number 7. How many cubes of some element would be required to equal 120 grams? So instead of giving you a known number of cubes, now I'm saying how many would we need if we want 120 grams. Let's let the substance be magnesium. Magnesium. I'll ask you to try to figure out what to do here and then check your work against the tape. You'll need to use your periodic table. The beginner's mistake is to use the molar mass and say this has some bearing on the question, but that is not a ratio of grams per cubic centimeter, so it's not useful. Instead, you want to go here and see that the density of magnesium is 1.74 grams for each cubic centimeter. That can be written as a ratio. Label every number. 1 cubic centimeter. And now I want 120 grams. And I'm looking for how many little cubes would that be? How many cubic centimeters? That's my setup. Algebra is a little more complicated than previously. 1.74x equals 1 times 120. This is my algebra. X equals 120 divided by 1.74. Use my calculator for that. I have an answer of 68.97. If I'm thoughtless, I'll say grams. If I'm thoughtful, x represents cubic centimeters. So now I think about my answer. Each little cube, if it's made of magnesium, is rather light, only 1.74 grams. So it does make sense that I would need many cubes, perhaps 69 cubes, to equal 120 grams of magnesium. The last question I'll leave as a question for thought. It's not a calculation question, really. You have to think about it.